All right, welcome to the video. In this video, we're going to be looking at section 8.3, where we're going to be graphing f of x equals ax squared plus bx plus c. So hopefully you're kind of noticing a pattern in the progressions of this section. So in 8.1, we saw f of x equals just ax squared. 8.2, we saw f of x equals ax squared plus c, and now we've added an additional term, bx, to this section. So we've asked, how does this change the vertex? Well, in previous sections in 8.1 and 8.2, all of the vertex coordinates were located along the y-axis. So if you looked at, your coordinate plane, in 8.1 and then also in 8.2, your vertex was located some here along this y-axis, depending on your value of c. But now that we have incorporated this term bx, it changes the vertex, especially when b is something else other than 0. So what we have to do now is we are going to use a formula. So what we're going to do to figure out um, what the vertex is, the first thing actually what we'll do is figure out what the axis of symmetry is, because then we can kind of go from there and figure out the vertex from there. So it says here, it says graphing f of x equals ax squared plus bx plus c. All right, so some things that you have to keep in mind. It says graph opens up when a is greater than 0. Graph opens down when a is less than 0. So basically when a is positive, it's a right side up U-shaped. When a is negative, it's the upside down U-shaped. All right, we talked about that in the previous sections. The next uh, thing that we are going to look at is the y-intercept. All right, the y-intercept is set, they say, is c. If you want to attach a coordinate to that, it's going to be 0 comma c. So in sections 8.1 and 8.2, our vertex and our y-intercept with the exact same coordinate. Because b is something else, it's going to um, change that status for the vertex, but the y-intercept is still going to be 0 comma c. Then I know it talks about the x coordinate of the vertex, but let's look at the axis of symmetry. That's actually what is the best progression from there. And the axis of symmetry, to find this dashed line, they're saying it's going to be x equals negative b over 2a. So where does b and where does a come from? Well, b comes from this value, this coefficient that's attached to x to the first power, and then the a comes from the coefficient that's attached to x squared. And then that's how you're able to determine where that dashed line is going to go. Then, when you're looking at the vertex, your x coordinate is going to be whatever that b, negative b over 2a is, comma, to find the y coordinate, you're going to substitute that number in for x, and then solve for f of x or y. I'm just going to put solve for y. So you'll take this value, whatever it happens to be, you'll place it in here, and you'll also place it here, and then you'll solve it from there because you'll have numbers for A, B, and C. Okay? So with that being said, first off, they're asking us, um, it says find the axis of symmetry and the vertex of the graph f of x equals 2x squared plus 8x minus 1. So what I like to do in these problems is write out the general form for a quadratic function, the ax squared plus bx plus c. Then from here, I want to illustrate what a, b, and c are actually going to equal. So I'm going to say a is 2, b is 8, and c is a negative 1. All right. Now, they don't ask this, but let's say they wanted us to graph this. I can say, all right, the y-intercept in this situation is going to be 0, comma, negative 1. So if I were to graph this, and I'm going to plot 0, comma, negative 1 here, that's where it would go. The second thing, and then this helps to solve the problem, is the axis of symmetry. Axis of symmetry is going to be x equals negative b. So since b in this case is a positive 8, it's going to be a negative 8 in the formula, divided by 2 times a, which is 2. So now I got negative 8 divided by 2 times 2, which is 4. And then this equals negative 8 divided by positive 4, which is going to be negative 2. So I find negative 2 on my graph, and then that's where I would place my vertical dashed line. To get the vertex, like I said, the x-coordinate comes from the axis of symmetry, which is negative 2, so I'm just going to plug that in. To find the y, this is where you substitute it in to this equation. You put negative 2 in wherever there is an x, and then you solve for y. So now this is going to turn into 2 times it by negative 2 squared plus 8 times it by negative 2 minus 1. Got to take care of order of operation, so we got to take care of this exponent. Negative 2 raised to the second power is going to be a positive 4. So positive 4 times it by 2 is 8, plus 8 times it by negative 2, which is negative 16, minus 1. So I got 8 plus a negative 16 minus 1. I get a negative 9. So negative 9 is my vertex. So I'm going to try to, get it roughly close to where it would be. Again, I don't have a graph, but I'm more interested in your labeling um, than your than anything else. And now here is where you're you're pretty sure you've done it correctly. So if you look, I have my vertex at uh, negative 2 comma negative 9. My y-intercept is way up here, which leads me to believe that it is going to be a right side up U-shaped parabola. And the only way that works out is if a is positive, y is negative 2. So it does work out in this scenario. And that's how you would graph it if they were to ask you to graph it. So here again, we have some scenarios where they're asking you to find um, the axis of symmetry and the vertex. So let's I'll do one. Let's do number 2 here. So I'm gonna say I'm just gonna write in ax squared plus bx plus c. So to find the axis of symmetry, a in this case is 1, b is 6, and C is 5. So axis of symmetry is going to come from the negative b over 2a. And sometimes if you just want to write it in, negative b over 2a, that's fine as well. So now this is going to be negative 6 divided by 2 times 1. Well, 2 times 1 is just 2. Negative 6 divided by 2 is negative 3. So my axis of symmetry is x equals negative 3. So that's my axis of symmetry. To find the vertex, the x-coordinate comes from the axis of symmetry. Now I just plug negative 3 into this equation here. So now I get negative 3 squared plus 6 times it by a negative 3 plus 5. So negative 3 squared is 9, plus 6 times 3 is negative 18, plus 5. So negative, or I'm sorry, positive 9 plus negative 18, and then plus 5, which gets you a negative 4. So negative 3 comma negative 4 is my vertex. Again, I encourage you to check questions 1 and 3 here. If you are struggling or are unsure, if you got the correct answer, please comment down below. Here it's asking you to describe the domain and range of this function, 3x squared minus 6x plus 5. So, like I said in previous videos in this chapter, anytime we're dealing with the quadratic, we're dealing with the domain, remember that's the set of x values. Is there a x value that you could not use? The answer is no. So in this case here, uh, my domain is going to be all real numbers. Now my range is the set of y values. Now there is going to be a set parameters for these particular sets, but it's going to be determined on where the location of the vertex is. So in order for me to find the vertex, I first have to find the axis of symmetry. So this is going to be x equals, well, negative b. Well, it's actually going to be positive 6 in this case because b is negative 6, divided by 2 times 3. So 2 times 3 is 6. That means my axis of symmetry is 1. So I'm just going to put 1 and make a dashed line there. My vertex is going to be 1 for my x-coordinate. For my y-coordinate, it's going to be 1 squared is 1, 1 times 3 is 3, minus 6 times 1 is 6, plus 5. So 3 minus 6 is negative 3, plus 5 is 2. So 1 comma 2 is my vertex. Now remember, something that you should keep in mind, your vertex is always going to be on the axis of symmetry. So if for some reason your vertex is not on the dashed line, you may have done something incorrect. So please check your work. All right, so to kind of help me out and just to graph it up. I know that C is 5, so that's my y-intercept, 1, 2, 3, 4, 5. Because my vertex is here, my y-intercept is here, A should be positive, which it is. So I'm going to have my right side up U-shaped value looking like so. So um, since my parabola is pointing upward, with respect to the range, it is going to be all real numbers except, or y must be greater than or equal to 2, because there's nothing below 2 that in terms of y, the graph is going to be on a table. All right, so you could choose any value for x, but your results for y are going to be greater than or equal to 2. last kind of concept that we are going to look at is being able to determine if your graph is a maximum or a minimum value. Okay, so here in this example, this is an example of a maximum value parabola, which means that the vertex is the highest point on that particular parabola. Here, in the second example, the vertex is the lowest point on the parabola, so that is considered to be a minimum value. So all you have to kind of determine if x is a minimum or maximum is determine what the value of a is in your function. If a is a negative number, if a is a negative number, your graph will be a maximum value. If your value for a in the function is positive, it is going to be a minimum value. And both the minimum and the maximum value will be your vertex. So if they ask you, all right, yeah, to tell me what, if it has a local, not local, it has a minimum or maximum value, all you have to do is, okay, is A positive or negative? And solve it from there. Then if they ask you to find that value, all they're asking you to find is that vertex. So in this question here, we are given this function, negative 4x squared minus 24x minus 19. They want you to find if it is a minimum or maximum value. Well, I got a is negative 4. Since a is negative, that means it is going to be a maximum value. All right, now they're asking you to find that value. I'll just keep adding on. B is negative 24 and C is negative 19. C is not as important to find the vertex. I'm just, keeping it consistent with the other findings in these particular problems. So in order to find that value, you need to find the vertex. Because you need to find the vertex, you also need to just determine what the axis of symmetry is, because that's going to give you your x value. So x will equal negative b, which is positive 24, divided by 2 times a, which is negative 4. So 2 times negative 4 is a negative 8. 24 divided by negative 8 is a negative 3. So my first coordinate will be negative 3. To find out what my y coordinate is I'm going to take this function here and substitute it in. So I got negative 4 times it by negative 3 squared minus 24 times it by negative 3 minus 19. So negative 3 squared, that's positive 9. 9 times that negative 4 gives me negative 36 right there. Negative 24 times it by negative 3 actually is a positive 72, and so that's minus 19. So negative 36 plus 72 minus 19 gives me 17. So negative 3 comma 17 is that maximum value. And that is being able to graph f of x equals ax squared plus bx plus c. Hope this helps. Till next time.